Hello to my favorite mathematicians, and welcome to Test 11, Lesson 6. Grab your swords and let's go. Today's objectives are to use number clues with decimals, combine fractions, and to understand theoretical probability. So let's have a look at number clues that involve decimals. So in order to follow number clues with decimals, you need to know the place value. Obviously this is the ones, and this should all be reviewed. This is the tenths, hundredths, and thousandths. Okay, and then it just keeps going, 10,000ths, 100,000ths, millionths, and so on. Usually this is about as far as we go with decimals, but these are the important three. So it's exactly the same as over here where we go 1, tens, hundreds, thousands, except we skip the ones and add a ths. So let's try a number problem. So it says start with 4.862, so that's what I'm going to do. And I should actually be reading that. The correct way would be to say 4 and 862 thousandths. That takes a really long time to say, so I'm going to keep saying 4.862. Just know that that would be the correct way to say it. So next it says make it 10 bigger. So that's what I'll do, make it 10 bigger. The tens place is here and I don't have anything there, so making it 10 bigger would mean adding a 10. And now I have 14 and 862 thousandths. Then it says decrease it by 4 tenths. So the tenths place value is here, and decrease 8 by 4 becomes 4. So now I have 14.462. Next up, I'm supposed to add 1 thousandth. So my thousandths are over here. So 14.46, and I'm adding 1, so 3. Next up, it says subtract 2. So I'm going to take 2 away. That will give me 12.463. Then I need to make it 3 hundredths bigger. So these are my hundredths. So if I add 3, that will become a 9, so 12.493. And what is the new number? Okay, so these look complicated sometimes, but they're really not. You just have to know the place value and then take it one step at a time. Next, let's talk about how to combine fractions. So here's a couple fractions, and the question asks me to write the shaded spaces as both a mixed number and an improper fraction. So the first thing I'm going to do is figure out what my fraction is. So I have 1, 2, 3, 4, 5, 6 pieces in each whole pizza. I'm just going to call them pizzas. So my denominator will be 6 because my denominator is always the number in the whole. And then on this side I have 1, 2, 3, 4 of them shaded. And on this side I have 1, 2, 3, 4 of them shaded. So I have 4 out of 6 plus 4 out of 6. If I count up all the shaded pieces, I'm going to get 1, 2, 3, 4, 5, 6, 7, 8. My denominator stays the same because my denominator, remember, tells me how many parts are in one whole pizza. That didn't change. There's still 1, 2, 3, 4, 5, 6 parts in one whole pizza. And then if I wanted to, I could write in. And again, you'll notice I just add the numerator. My denominator always stays the same. So that's it as as an improper fraction. I also want to write it as a mixed number. So thinking about that, what I would do is I have 2 empty spaces right here that need to get filled up. So I could move this one and this one over here. And then I would have one whole pizza with 1, 2, 2 sixths extra, 1 and 2 sixths. Other way to do that, of course, is to realize that if I do 8 divided by 6, 6 will go in one time. There will be one group of 6 with a remainder of 2. Same answer. That's all there is to combining fractions. So now finally let's talk about theoretical probability. So theoretical probability is what should happen in theory. So for example, if I toss a coin 6 times, the theoretical probability of getting heads 3 times would be 3 out of 6, because each time has a 50-50 chance. So out of 6 times, theoretically, I should get 3 out of 6. Experimental probability is what actually happens when you try the experiment. For example, I just tossed a coin 6 times, and I got heads 4 times. So the theoretical probability of getting heads when I toss a coin 6 times is 3 out of 6, but actually when I did it, I got it 4 out of 6 times, so the experimental probability was 4 out of 6. So again, theoretical probability, what should happen in theory; experimental probability, what happens when you try an experiment. We're worried about theoretical probability today. So here we have, I'm going to roll 2 6-sided dice, the red one and the blue one.
And I want to know the theoretical probability that when I roll them, they will both show 1s. So of course, probability is going to be the number of favorable outcomes over the total number of possible outcomes. So let's find out what those are. So the first thing I need to know how many possible outcomes there are. I know that there's only going to be one favorable outcome. There's only one way that I could roll the dice and get 1s on both of them. So whatever I'm getting for probability is going to be 1 out of something. Now, a lot of people would say 1 out of 6, but that's not accurate because you need to find out all the different ways the dice could show up. So here's the first set. If I roll a 1 on red, blue could be 1, 2, 3, 4, 5, or 6. So that's 6 possible outcomes for a total of 6, but I'm not done yet. And I'm not done because red could also be a 2, not just a 1. And if red is 2, blue could be 1, 2, 3, 4, 5, or 6. So that's another 6 outcomes. So when I put those together, I'm up to a total of 12 outcomes. Similarly, I could have a 3 for red, in which case blue could be 1, 2, 3, 4, 5, 6. That's another 6 outcomes. So 3 times 6, I'm up to 18 outcomes. And I'm not done yet. I still need to do 4, 5, 6. So here, red is a 4, blue could be 1, 2, 3, 4, 5, 6. That's another 6 outcomes. I add it to my total. I'm up to 24 possible outcomes. If red is 5, blue could be any of these. So there's another 6 outcomes. I'm up to 30. And finally, red could be 6, blue could be any of these. That's another 6, so I have a total of 36 possible outcomes. That means the probability, and you can see that only one of those outcomes, only one of those outcomes has both dice showing a 1. So the probability of getting a 1 on both is 1 out of 36, because there's only one way out of the 36 different ways the dice could show up their numbers that has both of them with a 1. Now you may have noticed that there's 6 sides on each die, and there are 6 times 6, 36 total possibilities. So because there's 6 on each side, one is going to go 6 different ways. This isn't writing properly, but you get the idea. One thing could go 6 different ways, and there's 6 of those. So it's going to be 6 times 1 times 6, 36. I can just do it that way, it's faster, but if that doesn't make sense to you, you can fill out the charts and it's not a problem. It'll just take you a little bit longer. You'll still get the right answer. Either way, the probability of rolling a 1 on both dice is 1 out of 36. And that's it, just a short review for you now. So number 1, start at 11.645, which should be 11 and 645 thousandths. Take away 4 tenths, add 40, add 100th, subtract 2 thousandths. What is the new number? Number 2, what fraction is shaded in all 3 pictures? Write your number as an improper fraction and a mixed number. And number 3, what is the theoretical probability of flipping 4 coins and getting all tails? So that's it. Get this review done, bring it in tomorrow, and I will see you then. Have a great night.